Hey class, welcome back. I hope you all had a fantastic Thanksgiving break. I sent all of you a private message, including to your parents if they have a linked Schoology account, that goes over what Mr. Dotson's live math classes are, but in short, I'll explain it here as well. So every single day, I will be hosting on Monday, Tuesday, Thursday, and Friday live classes for an hour and 30 minutes. Now, the difference between these live classes and my office hours is that I will be going over for an hour and 30 minutes what we're working with uh, each week. So, for example, this week on Monday, Tuesday, Thursday, and Friday, I'll be going over examples, problems that look like your homework assignments, and as if we were in class, the lesson that is in the video lesson. So it's basically the video lesson, but live if you have other questions that you want to ask face to face. Now, Wednesdays are still my office hours, and that's from 9 a.m. to 2 p.m. Now, the difference between a live class and the office hours is mostly just you can pop in at any time, and if you have any questions, you can ask me, and I'll just work with you one-on-one or in small groups. A live class is more I'm just giving out information, you're listening, and then if you have any questions, you can ask questions. Okay? So on Monday and Tuesday, I'll have live classes in our Mr. Dotson's Math Crew group. So the same place where we have the office hours on Wednesday. On Monday and Tuesday it'll be 9 a.m. to 10:30. And then on Thursday and Friday, I wanted to change the time up. It's from 12 p.m. to 1:30. Now, if, for example, there is in-person school on Monday and Tuesday, then I won't be able to have the live classes. These days are only built in if we're not able to meet in person. Okay. So if before Thanksgiving break, if we were virtual for an entire week, then I will be having live classes Monday, Tuesday, Thursday, Friday. Okay. So hopefully that helps. I'll be in contact with all of you to let you know if anything changes. But this is going to be my schedule for live math classes, and of course, my office hours are still the same, and they are all inside the Mr. Dotson's Math Crew group conference room. So where they've been all year long so far. Okay. All right. So let's hop into today's lesson. So for week 3, the only graded assignment is the 2-6 practice problems. All right. There's 10 problems and it's worth 15 points because this week is going to be a little bit more challenging in that each problem takes a little bit more time than usual. So that's the only graded assignment. You're also going to see inside week 3's folder Khan Academy practice. And what that is that it's a good way for you to watch videos that deal with finding distance on a coordinate plane of polygons, but it also goes into more detail. So if you want a bit of a challenge, it's not graded, but it's a good way to get review and to challenge yourself with more information dealing with coordinate planes and polygons and all of that. And then the last thing I want you all to be working on, some of us have not turned in the assignments from the weeks before Thanksgiving break. Please catch up. Don't fall behind. You need to stay on top of your assignments since we are almost halfway through this 9 weeks. Okay, and it's going to come up quicker than you might expect because we have winter break coming up shortly and only a few more weeks from now. Okay, so stay on top of your assignments. Um, I know breaks are coming up in it's the holiday season, but don't fall behind. Okay, and if you have any questions, please reach out to me. I'll be happy to help you. All right, so let's start with a warm up. So our warm up for this week is going over what we worked with last week before Thanksgiving break. It says find the distance between each pair of points. So I want you to find the distance between -2, 8 and 7, 8. And then also find the distance between -6.1, -8.4, and -6.1, -4.2. One thing to remember is that if you are trying to find distance, you want to figure out, are they in the same, it's too hard to see, are they in the same, or are they in the different quadrant? Okay, so figure out, are your x and y values positive or negative? If they are in the same quadrant, you subtract. If they're in different quadrants, you add. So take a minute, pause the video, see if you can figure this out on your own first, and then play the video again, and we'll go over it together. So let's look at this first one. -2, 8, 7, 8. Very first thing you want to do is figure out, is it positive or negative? Well, this is a -2, so that's negative. This is a positive 8, so positive. This is a positive 7, and this is a positive 8. Are they in the same or different quadrant? You have a negative, positive, positive, positive. They're different. So that means that you need to add the absolute values of the numbers that are not the same in each ordered pair. So the number that's the same in each ordered pair is this 8, right? So that means you need to add the absolute value of this -2 and the absolute value of this 7. The absolute value of -2, which means the distance from 0, well, -2 is 2 from 0, and 7 is 7. So what's 2 plus 7? 9. So your answer for the first one is 9. Let's try the second one. Let me change the color to blue. Again, the very first thing you want to do is figure out, are they in the same quadrant? The way you do that is you, right above each number, say, is it positive or negative? This is a -6.1 and a -8.4. This is a -6.1 and a -4.2. So you have a negative, 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 negative. Are they the same or different? They're the same. So when they're the same, you want to subtract the absolute value of the numbers that are different in each ordered pair. So you have -6.1 and -6.1. So those are not the numbers you want to work with. You want to work with this -8.4. So -8.4 and this -4.2. Okay, so this one has decimals in it, but take it one step at a time like we did in the other example. The absolute value of a -8.4 is just a positive 8.4. And the absolute value of a -4.2 is 4.2. The last thing you need to do is just subtract. Well, 8.4 minus 4.2 is just 4.2. And there's your answer. Okay, so hopefully you got the correct answers as well. If not, just see where you made your mistake and then change your answer and you'll be good to go. Okay, so let's dive into today's lesson. What we're going to be working with is we're trying to find the distance between points like we were last week, but we're going to be working with polygons. We're going to be working with shapes in a coordinate plane. And just to refresh our memory on what names we call different shapes, we're going to go over that first, and then we'll hop into finding distance and perimeter and area and all of that. So it's kind of like we were doing last week, but a little bit of geometry mixed in too. So one thing to keep in mind is we're going to be looking at polygons. And what a polygon is just a shape that has at least 3 or more sides to it, straight sides. So we're not looking at circles or anything like that because a circle doesn't have any sides, right? We're looking at things like a square, a rhombus, a kite, a parallelogram, a rectangle, trapezoid. All of these things are quadrilaterals because they have 4 sides, right? So we're going to be looking at these types of things, but not only shapes that have 4 sides, but also 3 sides like triangles. But let's go over some definitions because a lot of these different shapes kind of look similar. A square you all should be familiar with by now, right? A square has all sides equal, so every single side is the same length and the angles of each side, each corner, is 90 degrees, a 90-degree angle, which you may remember is called a right angle. A rectangle is kind of like a square, except all of the side lengths aren't the same length, so that's why it's not a square. But your opposite sides are equal, so this blue side and this blue side are the same length, and this top red and this bottom red are the same length. So opposite sides are equal, but the thing that's similar to a square is that every corner, every angle is 90 degrees. A parallelogram is as if you took a rectangle and just shifted the top and bottom a little bit, right? It's as if you smushed it. So a rectangle and a parallelogram are similar. And the way that they're similar is that these opposite sides are equal, right? That's what we said for a rectangle. But if you look at the angles, they're not 90 degrees. Since we shifted the top and bottom a little bit, your angles aren't 90 degrees. They're not perfect, right? But all this side and this side are parallel, and this top and bottom are parallel. Parallel just means that if I were to extend the lines, that those sides would never touch. They're parallel, right? Maybe you remember a trapezoid, and fun fact, inside the UK, it's called a trapezium, right? What a trapezoid is it's just that two sides are parallel, right? That's really the only thing that you need to remember from that. Two sides are parallel. This top side right here and this bottom side, let me draw on it. This top and this bottom are parallel. So a trapezoid only has two parallel sides because this side and this side are not parallel. If I were to extend them and extend this one all the way up, you see how they intersect? That means that they're not parallel. But this blue side and blue side, they are parallel because if I were to extend them, they would never meet. Now a rhombus is like a square, but as if I pushed in on the sides. It kind of makes a diamond shape, right? A rhombus, all sides are equal, so each side is the exact same length, and opposite sides are parallel. So this side is parallel to this side, and this side is parallel to this side, right? That's what a rhombus is. So it's kind of like a square because a square has all equal sides. My fingers don't change, right? My fingers aren't growing right now. A square but pushed in, that's a rhombus. So all sides are still equal, but my angles aren't 90 degrees, but my opposite sides are parallel. And then a kite is adjacent pairs of sides are equal. Okay, so this side and this side are the same length, and this side up here and this side are the same length. A kite is probably exactly what you think of. It's like a kite that you fly in the sky. That's what the shape is. Now, please, please, please remember to come back to this section when you take the 2-6 practice problems assessment, the homework assignment, because the definitions that you're looking for are right here. Okay, so please come back to this slide for your homework. That way you get the correct answers. Everything you need is right here. So we were talking about quadrilaterals, so shapes that have 4 sides. But what about your polygons that have 3 sides? Well, those are your triangles, right? Tri means 3. Triangles can also be classified in different types. One type of triangle that I want you to think about is called an equilateral triangle. What's the key phrase that you hear when I say equilateral? Hopefully you're thinking equal, right? Equal, lateral, equilateral. Equal means that something is equal, means that they're the same. And why I'm emphasizing that is because an equilateral triangle means that all sides of this triangle are the exact same length, right? So if we were to look at this triangle right here, this side, A and B, is the same as B and C, which is the same as C and A. They're all the exact same length. Okay, think of like a pool cue, right? This outside triangle isn't equilateral. the Illuminati. That was like a big thing, right? The triangle is an equilateral. This one right here, this triangle is an equilateral. Every single side is the exact same, okay? Another couple types of triangle is called an isosceles triangle and a scalene triangle. The difference between the two is that an isosceles triangle has two sides that are equal in length. So if you look over here, this side is the same length as this side. But if you look at the bottom, the base of the triangle, it's a lot shorter than the two other sides. So it's like a really tall triangle, but only the two sides are the same. That's an isosceles. And a scalene triangle, maybe you can guess it, is that no sides are equal. It's a really smushed down triangle, right? This side is 7 centimeters. This side's 12 centimeters. This side is 15 centimeters. None of the sides have the exact same length. That's why it's a scalene, okay? Now, if I were to change these lengths, if this side was 12 and this side was 12, then it would be an isosceles triangle because that means that two sides are the same length, okay? And if all of these sides were 7, 7, 7, that's an equilateral triangle because all sides equal the same thing, okay? Now, the stuff I just went over hopefully was a little bit of a review for you. One thing that might be brand new to you is this vocab word you're going to hear me saying all throughout the video, and that's called a vertex, or the plural version of it is vertices. So vertex and vertices, what that is meaning is just simply it's the corner of a shape, right? It's where two line segments meet to make a corner. So if you look at this shape over here, this square, this right here is a corner, right? It's where this line and this line meet. Well, that's called a vertex. And this is a vertex, this is a vertex, and this is a vertex. It's where your sides meet. And again, the plural version, this is a vertex. All of these corners, all of these vertexes are called vertices, right? On a triangle, here's a vertex, here's a vertex, here's a vertex. Those are the vertices. And later on in the year, when we start looking at three-dimensional shapes, you're going to see that three-dimensional shapes have many vertices. Okay, like on a cube, there's 1, 2, 3, 4, 5, 6, 7, and there's more that you can't even see. Okay, so again, the corner or the points where your sides meet are called a vertex or vertices. Okay, so with all of that being said, let's hop into what our actual lesson is going to be dealing with. So let me move me, can I make me smaller? No, so let me move me down here. So the first example says an archaeologist used a coordinate plane to map a dig site. She marked the corners, vertices, of a building with flags as shown. How much rope does she need to go around the building? So what we're trying to figure out is what is the perimeter of this rectangle? The first thing you want to do is just figure out, well, what are the ordered pairs, the coordinates that I'm working with? I have A, B, C, and D. So A's right here, B's right here, C's right here, and D's right here. We want to figure out what the ordered pair for each one of these would be. So let's first figure out what A would be. Here's A. So let's write that down, A. I need to figure out what's my X value. How far to the left is A? 1, 2, 3, 4. So that means my X value is -4. And my Y value, how far up is it? 1, 2, 3, 4, 5, 6. So the ordered pair for A is -4, 6. Let's do B. B is, it's over 1, 2. So that's a +2. And how far up is it? 6. All right. C. C also went over 1, 2. so the x value is the same as b, but it only went up 1. So there's my ordered pair for C. Let's do D, the last one. So D went to the left 1, 2, 3, 4. So it's -4. And the y value, it went up 1. So my y value is just 1. So that's the very first step in how to solve this problem. We want to figure out what the ordered pair for each one of these points would be. All right, the next step, we want to figure out what the perimeter of the rectangle is. Perimeter is just where you add up the side length of each of the sides of the rectangle, right? So if this were a rectangle right here, we want to figure out what is the perimeter, how much space is this thing going around, right? If you're able to, you could count. Some of you might be thinking that, and that's fine. If you want to count to find the perimeter, each box, that's okay. But sometimes you're not going to be able to because the coordinate plane isn't going to be going based off of units of 1. It might be going in decimals, or it just might not look right. Or they might not give you a ordered pair at all. They just might give you the coordinates. Sorry, a coordinate plane. They might not give you that. They might just give you the ordered pairs, right? So pay attention to both. Let's count first and just see what our answer might be. If we were to count from A to B, it would be 1, 2, 3, 4, 5, 6. From B to C, I would have 1, 2, 3, 4, 5. So if this is a rectangle, that means this is 6, this is 6, this is 5, this is 5. 6 plus 6 gives me 12. 12 plus 10 gives me 22. Oops, I have 23. 22 would be my perimeter. But let's use actual math to figure out if we're correct or not. So we need to figure out what is the distance between each one of these sides. So A, B, B, C, C, D, D, A. So A, B. We need to find what's the distance between A and B, so the side length of A and B. Well, just like what we did for our warm-up, what's the same between these two? We have 6 and 6. Are they in the same or different quadrants? Well, A's here in quadrant 2 and B's here in quadrant 1. So they're in different quadrants. Whenever you have something that is ordered pairs that are in different quadrants, you want to add. Well, what do we add? We add the absolute value of the numbers that are different. -4 and 2. So I have the absolute value of -4 plus the absolute value of 2. Absolute value of -4 is 4. The absolute value of 2 is 2. What's 4 plus 2? 6. Okay, so we found that the distance between A and B is 6, and we were right. Now let's find out what the distance between B and C is. So B and C, side length of B and C, we want to figure out, B is 2, 6, C is 2, 1. Are they in the same or different quadrant? You have a positive, 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 positive. They're both in quadrant 1 right here. So that means that they're the same quadrant, which means I need to subtract the absolute value of the numbers that are not similar between the ordered pairs. So if they both have 2 as x values, I need to work with this 6 and this 1. 6 and 1. The absolute value of 6 is 6. The absolute value of 1 is 1. 6 minus 1 is 5. So we did end up counting correctly. And remember, if it's a rectangle, that means the top and the bottom are the same, and the side are the same. So if we wanted to find the perimeter, we would have had to add 6 plus 6 plus 5 plus 5. 6 and 6 is 12 plus 5 plus 5 12 plus 5 is 17. Plus 5 is 22. So our answer was correct. All right. So what you're doing, what you're working on for 2-6 is that you're finding, just like we were last week, we were finding the distance between points. Well, we're doing the same thing. We're finding the distance between many points and adding them together. Okay. To find the perimeter or whatever it might be. Sometimes you might have to find the area, and we'll look at an example like that. Let's try another example. Okay, so here's example 2. It says a rancher maps the coordinates for a holding pen for his cows. How much fencing does the rancher need to enclose the cow's holding pen? All right, so let's look way over here. So a farmer or rancher wants to create a pen for his cows, so just fencing, right? And if you look, this is what I meant by sometimes it's not so easy being able to count, right? Because this is broken up in, it looks like what? Twos. So 2, 4, 6, 8, 10, 12, 14, 16. And then my ordered pairs have decimals in them. So it's not going to be very easy to count. We have to use actual mathematics to figure out distance between points to figure out our final answer. Okay? So you need to figure out the length of each side of this polygon and then add them up. So let's first start with L and M. L's ordered pair is negative 16.254 and negative 4.54. Well, looking at this graph that's made, are they in the same or different quadrants? They're in the same, right? Because they're both in quadrant 2 over here. Since they're the same, we want to subtract. Well, what do we want to subtract? For L and M, the side length of L and M, we want to subtract the numbers that are not the same in each ordered pair, which would be not those 4s. We want to subtract the absolute value, oops, I might not have enough room, but 16.25 minus the absolute value of negative 4.5. Okay, the absolute value of negative 16.25 is 16.25 minus the absolute value of negative 4.5, which is 4.5. When you subtract these two, you would get 11.75. So we have the side length now of LM. So this one's good. It's 11.75. Now we need to move on to MN. MN. So M and N, let me erase that. So the ordered pair for M is, again, negative 4.5, 4, oops, and N is negative 4.5, negative 6. Are they in the same or different quadrant? Well, M is in quadrant 2, and N is in quadrant 3, so they're different quadrants, which means I need to add the absolute value of the numbers that are not the same in each ordered pair. So for M and N, the numbers that are the same in each ordered pair is negative 4.5. So I need to add the absolute value of 4 and the absolute value of negative 6. Not too bad. The absolute value of 4 is 4. The absolute value of negative 6 is 6. My answer is 10. Okay, so we just did that one. M and N is done. The side length is 10. So now we want to find the side length of NO. So the ordered pair for N is negative 4.5, negative 6, and O is 8.25, negative 6. N is in quadrant 3, and O is in quadrant 4. Since they're in different quadrants again, we want to add the absolute value of the numbers that are not the same in each ordered pair. So the number that is not the same in each ordered pair would be negative 4.5. So negative 4.5 and 8.25. So the absolute value of negative 4.5 is just 4.5 plus the absolute value of 8.25, which is 8.25. When you add them up, you get 12.75. So that is another side length that we have now found. So NO, the side length is 12.75. The last side lengths we need to find is OP, PQ, and QL. So 3 more to go. We're halfway there. So in order to find the side length of OP, same thing as the other, we need to figure out, are they in the same or different quadrants? O and P are in the same, so that means I would subtract, so O and P, I would subtract the absolute value of the numbers that are not the same. The numbers that are not the same are a negative 6 and a negative 12. Since we're subtracting, I'm going to write the negative 12 first. So negative 12 minus negative 6. The absolute value of negative 12 is 12. The absolute value of negative 6 is 6. 12 minus 6 gives you 6. And there's your side length for OP. 2 more. Q and P, they are in different quadrants. So for Q, P, let's choose a different color so it doesn't look too messy. The numbers that are not the same are negative 16.25 and 8.25. Since they are in different quadrants, you want to add the absolute value of 8.25 and add the absolute value of negative 16.25. Kind of got jumbled up there. When you do that, your final answer should be 24.50, so 24.5. And that's all the way down here. So 24.50. And the last one, QL. They are in different quadrants. So for QL, since they're in different quadrants, we want to add the absolute value of the numbers that are not the same. The numbers that are not the same are negative 12 and 4. So negative 12 plus the absolute value of 4. Well, what's 12 plus 4? 16. So I know that was a lot of math, and that's why I'm saying that this lesson takes a lot of time, which is why your homework assignment is worth a lot of points. Okay, so what I'm going to do is I'm going to erase all of this and write down the side lengths of all of the sides that we just found. So what I did is I wrote every single side length in order, and if there were decimals, I lined up my decimals, I added zeros, so this is what it looks like in the end. All you want to do is you want to add them all up to see what your answer would be to find the total perimeter of this irregular polygon. So 5 plus 5 gives me 10, so I write a 0 and a 1. 1 plus 7 is 8, plus 7 is 15, plus 5 is 20, so you put a 0 and a 2. 2 plus 1 is 3, plus 2 is 5, plus 6 is 11, plus 4 is 15, plus 6 is 21. So I write a 1 and a 2 up top. 2 plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 2 is 7, plus 1 is 8. Last step, bring down your decimal. So that means that the total perimeter of this irregular polygon is 81. So to talk about what the question was actually asking for is how much fencing does this farmer or rancher need? He needs 81, and I believe it is yards. So 81 yards worth of fencing. Okay, so that's how we can use what we're working with in a real world situation. So if you ever need to do fencing, or if you're trying to find the perimeter of something, yes, you can measure it out. But when you are trying to find the total perimeter of something, you're going to have to add all of your total measurements up. And this is one way you can do it using a coordinate plane. Let's try one more example. Okay, so for example 3, it says, are triangle ABC and triangle BCD isosceles? Explain. So if we remember back to when we were talking about the different types of triangle, isosceles means that two side lengths have to be the same. So it's asking, is triangle ABC and BCD, are they isosceles? So one thing we want to do is we want to look at the triangles themselves. Well, we see just visually we see that AB, this side of this triangle, is probably the longest. It is the longest of ABC, right? And for BD, it's the longest side of the triangle BCD. So let's not focus on those sides, right? Because if we know that they're the longest, then they're not going to be the same as the others. But what we don't know is the side BC the same as CA? And is the side BC the same as CD, right? That will tell us if my triangles are isosceles. So let's find the side length of AC. We first need to figure out what the ordered pair for each one is. Well, it looks like this coordinate plane is counting up by ones. So -1, -2, -3, -4, -5. So this is -5, 2. So A is -5, 2. Oops, -5, 2. And B, the ordered pair for B is, it looks like 1, 8. So my X value is 1. My Y value is 8. My C, point C, is 1, 2. And let's get the ordered pair for point D, because we're going to have to work with that too. Point D is, if this is 1, 2, 3, 4, 5, 6, 7, 2. So 7, 2 is my ordered pair for point D. So we have all of the points that we need to work with, okay? We want to figure out what is the side length of AC. So the side length of AC. Well, what do we see for AC? What is the same? 2 is the same, right? Are they in the same or different quadrants? Here's A, here's C. C is in quadrant 1, A is in quadrant 2. So that means that they're in different quadrants, which means we add the absolute value of the numbers that are not the same between the ordered pairs. So that would be -5, and that would be 1. The absolute value of -5 is 5, plus the absolute value of 1, which is 1, which means your answer is 6. So the side length of AC is 6. Let's find the side length of B and C. So from B to C, let's choose another color. Side length B, C. Well, here's my ordered pairs for B and C. Are they in the same or different quadrant? Here's B, here's C. positive, 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 positive. They're the same. So I would subtract the absolute value of the numbers that are not similar in the two ordered pairs. So if 1 and 1 are the numbers that are the same, I want to subtract 8 and 2. So the absolute value of 8 and the absolute value of 2. So the absolute value of 8 is 8. The absolute value of 2 is 2. 8 minus 2 is 6. Okay. So the side length of B and C is 6. Let's find this last side length, C and D. So let's choose another color. Let's find the side length of C, D. Here's the ordered pair for C. Here's the ordered pair for D. They're both positive, 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 which means that they're in the same quadrant. We can see that they are. They're both in quadrant 1. So since they're in the same quadrant, we want to subtract the absolute value of the numbers that are not similar. So if they both have 2, a y value of 2, I want to subtract a 1 and a 7. So let's subtract 7 and 1. Absolute value of 7 is 7. Absolute value of 1 is 1. 7 minus 1 is 6. So the side length of C and D is 6. Okay. The whole question is asking, is the triangle ABC and the triangle BCD, are they isosceles? And the definition of an isosceles triangle is that it has 2 equal side lengths. So let's look at A, B, and C. Do they have 2 equal side lengths? A and C is 6 and B and C is 6. Are they the same? Yes. So ABC is an isosceles triangle. How about BCD? BCD is, let me highlight that in another color. Here's BCD. Is it an isosceles triangle? Does it have 2 equal side lengths? 6, 6. Yes, it does. So the question is asking, are they isosceles triangles? Yes. Yes, they are. And then you're done. Okay, so let's try one practice problem that looks similar to what you will see on 2-6, and then we'll be done for this lesson. So here's what you want to do. Your 2-6 practice problems on Schoology is going to have a problem that looks similar to this over here. Let's work through it, and hopefully it gives you a better idea of how to tie everything we've just learned together. So if you look, there is no coordinate plane that is drawn for us. So we're going to have to use the ordered pairs of the vertices that are given to us. It says Jen draws a polygon, so a shape that has more than 3 sides, with vertices E, -2, 3.5, F, 3, 3.5, G, -1, 1.5, and C, H, which is -2, -1.5. It's saying, is EFGH a square? Justify our answer. So a square means that it has all equal sides. All equal sides. So if this helps, draw a picture. It doesn't give us a coordinate plane, but let's draw a picture. So let's assume I made a square, right? Let's say this vertice was E. Let's say this side was F. Let's say this vertice was G. And let's say this vertex was H. Okay? Now we want to figure out, is this a square? And a square means that every single side has to be the same. Let's see. So let's figure out, what is the side length of EF? EF. The ordered pair for E is -2, 3.5, and F is 3, 3.5. Are they in the same or different quadrant? -2 is negative, 3.5 is positive. 3 is positive, 3.5 is positive. So we have a negative, positive, positive, positive. Are they the same or different? They're different. Whenever it's different, you need to add the absolute value of the numbers in each ordered pair that are not the same. So that means that I need to add the absolute value of -2, right? Because here's -2. I need to add the absolute value of 3. -2, the absolute value is 2. 3, the absolute value is 3. You add them together, you get 5. Okay, so that means that this side length of E and F is 5. So 1 down, 3 to go. Let's do FG. So let's choose another color. F and G. So let me erase this. So for F and G, let's figure out, are they in the same or different quadrant? We have positive, 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 negative. Well, those are different. So again, we're going to have to add the absolute value of the numbers that are not similar in each ordered pair. The numbers that are not the same would be this 3.5 and this -1.5. So 3.5 plus the absolute value of 1.5. So far, so good. The absolute value of 3.5 is 3.5. The absolute value of -1.5 is 1.5. So if we add these together, 3.5 plus 1.5 gives me 5. Okay, so we just found that F and G, the side length is 5. So far it's kind of looking like that it is going to end up being a square, right? But we want to make sure that we're right first. We don't want to just jump to conclusions that it's correct. We want to test all sides. So let's choose another color. Let's find the side length of H and G. H and G. Same thing as before. The ordered pair of H is -2 and -1.5, so those are both negatives. And for G, we said it was a positive and a negative. Are they the same or different? They're different. So we want to add the numbers, the absolute value of the ones that are not the same in each ordered pair. So for H and G, the numbers that they don't share are 3 and -2. So we want to find the absolute value of 3 and the absolute value of -2. 3 plus 2 is 5. So we are looking good still. E and F is 5, F and G is 5, and H and G is 5. Let's just double check to make sure that E and H is also 5 before we can justify our answer. So for E and H, we'll do it down here. E and H, the side length. I need to figure out, are they in the same or different? We have a negative, positive, and for H, we have a negative, negative. They again are in different quadrants, which means you add the absolute value of the numbers that they don't have in common. The numbers they don't have in common would be 3.5 and -1.5. So we have the absolute value of 3.5 and -1.5. Well, if you look over here, F and G, we had this exact same problem. We know the answer is 5. So if each side length is 5, is it a square? Yes, because all side lengths equal 5. And that is what you are going to be working on 2-6 practice problems on Schoology. Hopefully that made sense and you can get great scores. So that's all I have for you for this week. Just to remind you, I will be having live classes on Monday, Tuesday, Thursday, and Friday of this week. The reason is because we are only virtual, so my in-person students and my virtual students, you are able, if you would like to attend on one of those live classes, feel free, hop on. It will be on the Mr. Dodson's Math Crew group, and I can go over any questions you might have. I'll be going over examples similar to the ones that are on your homework assignments, And then Wednesday, as always, so I've been doing this whole school year from 9 to 2 p.m. I have office hours. So you can join in, ask questions one-on-one or in small groups. I can help you out there as well. So please, please, please join. Ask questions. If you don't join any of those, you can still send me a message on Schoology and I'll get back to you as soon as possible. So if I don't see or hear from you all, I hope you have a great week. Keep up the good work. Please catch up on the assignments that you may be missing. And until next time, I will see you in our next video.